Hey there, in this video we'll explore how capacitive proximity sensors work and why they're so important in the industry. Capacitive proximity sensors are critical devices in industrial automation, allowing objects to be detected without physical contact. Unlike inductive sensors, which only detect metals, capacitive sensors can detect a wide variety of materials including plastics, wood, glass, and liquids. Due to their high sensitivity and accuracy, they're used in applications such as level control, part detection in assembly, and product monitoring on conveyors. Now we will see a little history. In 1745, Ewald Georg von Kleist and Peter van Mussenbroek discovered the principal capacitance with the invention of the Leyden jar, a device that could store electrical charge. This discovery laid the groundwork for the development of capacitors and eventually capacitive sensors. In 1831, Michael Faraday studied capacitance and the behavior of the dielectric materials, establishing the theoretical basis for capacitive sensors. In 1920 to 1930, the first experimental capacitive sensors are developed, used in laboratories to measure humidity and the electric properties of materials. In 1940 to 1950, during World War II, capacitive sensors are used in military equipment and radar systems to improve the detection of objects and aircraft. In 1960 to 1970, with the advent of industrial automation, capacitive sensors began to be used in manufacturing for quality control and non-contact detection of non-metallic materials. In 1980 to 1990, more compact and more accurate capacitive sensors are introduced, thanks to advances in microelectronics and advanced electric materials. They begin to be used in liquid level control and detection on conveyor belts. In 2000 to 2010, capacitive sensors with digital technology, sensitivity adjustments, and industrial communication emerge, which improves their integration into automated systems. In 2010 to present, intelligent, ultra-high precision capacitive sensors are developed, using touch screens, medical devices, robotics, and advanced automation systems. Principle of operation. The capacitive proximity sensor works by creating a high-frequency electric field on its sensing surface. This field is generated between two conductive plates inside the sensor, forming a circuit equivalent to a capacitor. When an object enters the sensor electric field, its dielectric constant alters the capacitance of the circuit. The higher the dielectric constant of the material, the greater the variation in capacitance, along with the sensor to detect non-metallic materials such as plastic, glass, or liquids. The sensor continuously measures the capacitance of the dielectric field. When an object approaches, the capacitance increases, and upon exceeding a predefined threshold, the sensor activates its output, sending a signal to a controller or automation system. Some capacitive sensors include an adjustment potentiometer, which allows the sensitivity to be modified to detect objects at different distances or to filter out the specific materials. This is useful in applications such as level sensing intents, where it is necessary to distinguish between liquids with different dielectric properties. Classification. According to output configuration, capacitive sensors with PNP output, used in control systems with positive logic, current flows from positive to negative, common in Europe and in applications with modern PLC controllers. Capacitive sensors with NPN output operate with negative logic, current flows from negative to positive, used in electronic systems in Asia and in some industrial equipment. Representative device. EDON E53 It is designed to detect both metallic and non-metallic materials, including liquids, plastics, and granules. It is ideal for applications where mechanical limit switches are not effective, such as in the detection of light or small objects. Its detection range is up to 20 mm, adjustable according to the application. It has PNP or NPN output options, normal, open, or closed, and its supply voltage is 10 to 30 volts DC. The prices range from 80 to 150 USD, equivalent to 300,000 to 600,000 COP. Pepper Flutes CBN50. Pepper Flute offers the CBN series of capacitive sensors designed for the precise detection of conductive and non-conductive materials. They are ideal for applications such as level control, detection of plastic liquids and granules. Its detection range is up to 15 mm, adjustable by potentiometer. It has models with PNP output with normally open contact configuration, and its supply voltage is 10 to 30 volts DC. The prices range from 100 to 200 USD, equivalent to 400,000 to 800,000 COP. Allen-Bradley Rockwell Automation. The Allen-Bradley 875C series is designed for industrial applications that require the detection of a variety of materials, including non-metallic solids and liquids. These sensors have an adjustable sensing distance and versatile output options. Its sensing range is up to 16 mm, adjustable to suit different applications. It has PNP or NPN output options with normally open or closed contact configuration, and its supply voltage is 10 to 48 volts DC. Their prices range from 150 to 300 USD, equivalent to 600,000 to 1,200,000 COP. Applications: Automotive industry. Detection of presence and position of parts in vehicle assemblies. Monitoring of fluid levels such as oil, coolant, and fuel. Quality control in production lines. Food and beverage industry. Control of liquid and solid levels in containers and tanks. Detection of plastics and glass containers in bottling lines. Process automation in packaging and bottling machines. Electronics industry. Detection of printed circuits and components in assembly systems, using capacitive touch screens for mobile devices and computers. Proximity control in contactless interfaces. Pharmaceutical industry. Control of liquid levels in bottles and storage tanks. Detection of plastic containers in production lines. Automation in filling and packaging processes.